All right, let's take a look at some examples of span. I've got my Legos down here, right? It's a pretty sweet Lego set, thanks. So the question is the vector v equal to 5, negative 2, 8, 10 in the span of these three vectors in S? 1, 0, 1, 0, negative 2, 3, 0, 1, and 1, 1, 0. And this is the same thing as saying, let's see, if this is vector 1, vector 2, and vector 3. Is there some multiple, like 5 of this brick, plus 3 of this brick, plus 6 heads here? Can I construct this very specific spaceship? So more specifically, I guess, does there exist, is there a C1 times 1, 0, 1, 0 plus C2 times negative 2, 3, 0, 1 plus C3 times 1, 1, 1, 0. That will give me 5, negative 2, 8, and 10. So if we use a little bit of matrix scalar multiplication and then add these together, this is C1, 0, C1, 0, plus negative 2C2, 3C2, 0, C2, plus C3, 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 0 is equal to 5, negative 2, 8, and 10, which is the same thing as asking is C1 minus 2C2 plus C3 equal to 5, as those are the positions, in each one of my individual vectors that will combine to give me that first position. What am I talking about here? So let's blow this up a little bit. The only way that I'm going to get a 5 in the top position in this vector is if I add up the top components. And so that gives me my first equation here. My next equation will come from adding up the second row. And so I will get the equation 0 plus 3C2s plus C3 is equal to negative 2, and so on and so forth. So this will be C1 plus C3 is equal to negative, is equal to 8. Let me erase that. Is equal to 8, and then it looks like just C2 is equal to 10. So this is a linear system here. Let's see, let me move some of these beautiful Lego pictures out of the way here. Oops. This is our next little example. I was not prepared for all this writing. Okay, so that's my system, and then that means I can rewrite this as an augmented system where actually those scalar coefficients are my variables. That is to say, this is 1, 0, 1, 0, negative 2, 3, 0, 1. Or if you like, the top row is 1, negative 2, 1, and 5. The second row is 0, 3, 1, negative 2. The third row is 1, 0, 1, 8. And the last row is 0, 1, 0, 10. And there's a couple of different ways we could solve this. One is a straight row reduction, or we could use a determinant here. Let's go ahead and just do some old school row reduction. This is row equivalent to, let me actually move this over so that I have some room. This is row equivalent to, I'm actually going to take the third row and make it my first row. So that's row 1 is being switched with row 3. So let's see, 1, negative 2, 1, 5 down there in the middle. And then I'm going to take row 4 and make that my row 2 just because it has the pivot in the right position. Whoops, I've screwed something up. I want to make row 4 my new row 2, and that has a 10 in the last position. My eyes are going crazy. 10. And that makes this 0, 3, 1, negative 2. So this was row 4 and row 2 are switched. Okay. That is row equivalent to 1, 0, 1, 8, 0, 1, 0, 10, and then 1 times just row 1 minus row 3 is my new row 3. And that will give me 1 minus 1 is 0. 0 minus negative 2 is 2. 1 minus 1 is 0. And 8 minus 5 is 3. And then I have, let's see, 3 times row 2 minus row 4 is my new row 4. And so that'll give me 0. 3 of those minus that is 0. 3 zeros minus 1 is negative 1. And 3 tens minus negative 2 is 32. Sorry, positive 32. Okay. Now, that's row equivalent to 1, 0, 1, 8, 0, 1, 0, 10, 0, 1, 0, 3 halves, and 0, 0, 1, negative 32. So what I did was I did negative row 4 is my new row 4. And I'm actually going to just subtract these. So this is, let's get rid of this middle row here. Row 3. Let's go back and do a better row operation there. Let's do twice row 2 minus row 3. So that'll give me 0, 0, 0, and then 20 minus 3 is 17. Now don't forget that this is an augmented matrix. And so actually what's happening here is I have an inconsistency. Now I don't have to go all the way to REF or RREF form, but this is inconsistent. There is no solution, which means there is no C1, C2, or C3 such that C1 times V1 plus C2 times V2 plus C3 times V3 is equal to V in general, or this vector here does not lie in the span of S. And so let's actually rewrite that here. Come on. 5, negative 2, 8, 10 is not a member of the span of S, or is not in the span of S. So that means that there is no combination of red bricks, blue bricks, and pirate skulls to make my ship here. Not going to happen. I don't have the bricks necessary to build the ship. We'll take a look at the next example in the next video.